Thank you for that introduction. So just real quick, want to get people oriented with what kind of we do day to day with SRE. So we work specifically on the GeForce Now platform. I don't know how many people may have tried that or played it. It's basically an online game streaming platform. If you haven't tried it, you can go sign up for an account. They have free accounts. Give it a shot. We work on a global SRE team of about 26 people, primarily located between India and North America, with a few other people sprinkled around the world. I think the big thing that I want to call out is we have about 150 plus services and components that make up our service that we are constantly trying to monitor and keep up and running, and generally make reliable. In all honesty, there's probably 20 to 25 of those are like core services that we deal with 95% of the time. But this kind of gives you a sense of the breadth of issues that we are trying to deal with. It's to the point where a single human can't know everything that's going on across our service all the time, and it is a constant struggle to try to analyze and figure out problems as they come in. We also manage deployments across 35 different locations around the world. I think I was doing the math last night. I think we have co-locations on every continent except Antarctica that we're actively managing pretty much 24/7 with 25,000+ physical servers, which probably comes out to 100,000 plus GPUs that we're managing as well. And then also some services on various cloud service providers. So the big question, why should SRE use AI, right? The big obvious answer is it saves us time in a lot of different ways. So in our context, a lot of what we're using it for is for on-call related issues. Again, as called out, we support a lot of different servers and services. And ultimately, we use AI to help us narrow down root causes faster. Rather than bouncing between different dashboards, alert consoles, logs, things like that that might take 20, 30 minutes just to try to scope out a problem, we can use AI to sort of narrow that down much more quickly. It also helps reduce misescalations. That is another big problem that we've always been fighting. Again, with so many different services and service owners, it can be difficult to figure out who is the first one we need to be calling when we see a particular issue pop up on the site. And I'm sure, as a lot of people have experienced, service owners don't like to be called unless they absolutely need to be called. So there are certain teams that get abused more than others because they get the first call very often, because just a lot of our signals are very mixed when trying to figure out exactly what's going on. AI also helps us streamline reporting, so daily, monthly, weekly, executive reports, all that kind of stuff is aided by AI. So one good example is a lot of our, we do weekly service reviews with the entire product team, and historically it used to take 2 to 3 hours to sort of prepare a report of everything that kind of happened over the week. We can get that down, that 2 hours of work can be done in probably 5 minutes of work using AI tools, and then a couple extra minutes used to organize thoughts and things like that. So we do see a massive saving of time on a lot of our reports. Postmortems, similarly, we use various AI tools, excuse me, to make our postmortem process a lot easier. So we're a group that uses Slack a lot for managing our incidents. So all of the incident data ends up in a Slack channel somewhere. We have tools that will go through, summarize everything that's happened on Slack, and will create postmortems for us in the format that we desire, which again saves a lot of time so we can get focused on actually identifying corrective actions, not so much time on just trying to transcribe things that happened during the incidents. The other big thing is non-SRE questions. So we are usually the first stop for a lot of people across the company when they have a question about something going on at the site. We have one of our VPs, he is an avid gamer. He uses our service all the time. He's also an avid Reddit reader. So he'll go to the GeForce Now subreddit, He'll go in there. He'll see people talking about, hey, we're having a problem in our Bulgaria region, and he'll then come to us and say, hey, is there a problem in Bulgaria? And of course, the SRE engineers who get those requests, they see that there's a request coming from a VP, so they end up dropping everything they're doing to try to go answer this question for the VP. And so it may be something easy where it's like, yeah, we're already working on something, or it could be a red herring, but we end up spending an hour trying to figure out if there's a problem because a VP saw a post in Reddit somewhere, and it basically spun everybody up. So we're working on solutions that will allow non-SRE people to go in, ask questions about the status of things, and it'll identify their role in the company, and it'll give them an appropriate response based on kind of who they are, right, as far as things go. So it'll recognize that, hey, this is an executive. Let's give him only the details he needs to answer his questions so that, A, we don't get bothered, but also so he can move on with his day and go work on things that are more important to the company. And then also, I think everybody probably understands speeding up the development time. We are engineers at the end of the day. We want to be building solutions to problems. We don't want to be dealing with incidents. But in our case, it seems like we are dealing with incidents far more than we want to be doing it. So a lot of the Copilot applications we use to help with the development process. It also is very good at bridging skill gaps on the team. So I'm sure a lot of people have run into it on their teams where individuals are very strong in certain areas, right? So example, like Aravind, when he joined our team, he worked on a bunch of dashboarding. And so now guess who gets all the questions when there's a problem with dashboards, right? Everybody goes and asks Aravind, which is not a good use of his time and his skill set at this point. But with a lot of the AI tools, people can now start to self-serve. They can use AI to answer questions for them. They don't need to be using other people's times. So why is it hard for us to adopt AI solutions? Because we do get pushback in various ways. And probably dating myself with this reference, but at the end of the day, we fear change, right? Change is the cause of a lot of the problems that happen on the websites, and what drives a lot of the incidents. And so we're naturally risk averse. We don't want to introduce new things into our processes that might slow us down or might cause us more problems. And AI obviously has certain issues with trust in certain areas where you're scared to introduce certain AI solutions because you're afraid that maybe the answers that it's giving back to you or the data it's giving you is not absolutely correct, right? And so, like it says here, hallucinations are real. And so there are strategies you can use to sort of mitigate some of those risks from hallucinations and other things. Another potential problem is pushback internally, right? So your security team might have problems with how you implement certain AI solutions, right? I think the security teams are probably more paranoid than SREs are in general. They care about where is data being stored, who has access to it, is it off-prem somewhere, or is it staying inside? We've struggled with this with our security team quite a bit, trying to answer all those the questions for them so that they can feel comfortable with the solutions that we're trying to do. And Aravind will talk a little bit about some of the practical ways that you might be able to quell the fears of your security teams. The other thing is lack of executive support. So this isn't so much that they don't believe in what you're doing, but it's more about there's other priorities that need to be worked on. And a lot of times AI solutions might get pushed off to the side because there's things that need to be done right now. And this seems to be, a lot of the AI stuff feels like it's something, yeah, we want to get to eventually, but eventually never really comes, right? And you might also run into where, up the management chain, people are dubious about how much actual value AI solutions can bring to the product you're working on. And hopefully through some of the examples we have, you'll see that there is value there to be gained. So the big question is, where do you begin? So you can start small, right? And so I think we all understand AI is pretty good at summarizing summarizing content for you, right? So you can set up a very simple thing where you're just having it summarize your playbooks, your documentation, your design docs, whatever the content is that you're using to, that you need to be summarized so people can just very quickly find solutions to problems or answers to questions. While this is probably the easiest one to set up, it might be the hardest one to get right. And that's mostly because it requires that the content that you're feeding into the LLMs to be accurate. And in my 25 years working in the SRE realm, I don't know that I've ever worked on a team that was good at maintaining documentation. So I don't know. Hopefully you guys are in a better situation, but generally there's a lot of old documentation, a lot of cruft just sitting around. Also lack of standardization of the content makes it hard to get good, accurate summarizations that you can trust. So that's probably one of the biggest things that, biggest muscles that need to be flexed when trying to implement solutions when it comes to summarization. Moving on to kind of the next level of complexity, there's the synthesizing of information. So this isn't so much just summarizing content. This is actually going out and looking at real-time information across the site. So it's things that'll go look at your metrics, your SLOs, your logs, like all those things at once, and you'll ask the questions like, hey, what's going on in Bulgaria? And it'll come back and say, this is all the information I know about the current state in Bulgaria, right? And it'll list all these things out. You can have it be pretty, give you graphs, things like that. So you kind of get everything on a single pane of glass presented to you just by entering, a common language query, which will help, again, speed things up in the incident context. So you're not spending 20 minutes trying to aggregate data. This will aggregate the data for you in less than a minute. So the next level of complexity beyond that is evaluation. So this is where AI is actually giving you suggestions of what you should be doing or where there might be a problem, right? So it's actually making some sort of a qualitative assessment of the situation. So we're currently implementing a Bayesian network-related system that'll go through and figure out where your most likely problem is if you get a series of alerts coming in. It understands the network layout, all the dependencies, and it'll recommend to you, like, hey, this is most likely the component in your system that's causing you the problems. And it allows you to very quickly narrow down where you're investigating and where you're searching. And it also kind of helps with some of those mis-escalations if you need to go that route. And then the final one, which is probably the most interesting but also the most scary, is having AI actually take action on the site. Right, so this is where you take that evaluation portion and then you actually give AI agency. And so we also have some solutions that we've been working on that will allow AI to do these, to take action and actually correct things on our site. Obviously, there's hesitation around allowing an AI to just, restart a service or whatever, something that seems very simple, but you're afraid that it might go through and just blow away everything, accidentally. But there are some methodologies that you can use to sort of mitigate the risk that you're going to have some sort of a Skynet moment on your service. And you can also still build in checkpoints where humans still review actions before you actually have an action taken on the live site. And so with all that being said, I'm going to hand it over to Aravind. He's going to go over some of the practical implementations of some of these concepts.
Thanks, Scott. So I'll get started on building a little more AI muscle in an SRE team. Now, most engineers are really good at what they do, and there is generally a little bit of inertia to try out a new AI tool. And to that extent, there should be an attempt made to at least pick entry points that match how you already work. So if you're someone who uses a terminal quite a lot, then try using an AI terminal and asking questions in natural language. Like if you have a git log comment that you want, maybe you can ask for that in natural language, and it works most of the time. Another way, like if you're more of an IDE person, then you can just add an AI extension to your IDE, and that immediately starts adding value too. You can ask questions about a code base that you're working with, like for instance, something like, oh, where is the timeout implemented? And it can actually help move you a little bit faster in like trying to understand where things are. If you're concerned about like security or like sensitive data leaving your network, there are self-hosted and open source options available for pretty much everything. But these tools are often focused on individual productivity, and sometimes you want to build a shared solution for your entire team. And that's where you kind of need access to an LLM API. So there are many ways to go about this. You can get like an enterprise API, like from any of the cloud providers, or you could try to host one yourself. But the general rule should be that you should try and choose the smallest thing that solves your problem. If for your team of like 20, 25, or even like 100 people, if a managed API with logging disabled meets all the needs, then just start there and move to a self-hosted solution when specific limits like cost, latency, or privacy come in. And when it comes to hosting AI models, it's actually really straightforward to do. Most modern runtimes have made this process incredibly easy. One that I'm quite familiar with is NVIDIA NIMs. And it's more or less like you would select and download the NIM for the model that you want, and you run the container. And you more or less have an LLM API running in under 5 minutes. Now, there are other open source options as well. You can download weights of Hugging Face or any other place where you get your model weights, and you can use inference engines like VLLM or SGLang, and you have an LLM API running which you can use to do things. Yeah, so we have an API. Now, what's the place where we can get started and add some value? Well, the easiest thing is to like make a RAG server. RAG stands for Retrieval Augmented Generation. And this was all the rage in 2024. In short, all it does is before it answers a question, it does a Control F across all your documents and finds the right passages, adds that along with your question, and then gives it to an LLM so that the language model is answering based on the exact passages that it has identified, rather than just hallucinating and saying something straight out of it. And it's fairly straightforward to get started with a RAG server. You get all your documents, break them down into like pieces, and it goes through an embedding model. And the embedding model creates embeddings that you store in a vector database. Now, the next time you ask a question, your question also goes through an embedding model, and an embedding is generated. This embedding, you can use it to like search and find the relevant other passages in your vector database corresponding to the question, essentially get all of that right information, give it to the LLM, and generate a response. It's really straightforward to do and starts bringing in value on something that's fairly straightforward to do and like your team can start using. But even though a basic RAG is like fairly straightforward to do, building something production grade can involve a lot more things. Like you need better accuracy, you need good guardrails, you need knowledge grounding. And the thing is, RAG, 2024, everyone was behind RAG. So there are tons and tons of like resources and blueprints available. If you see this image, that's a lot more complex than the last one because it has re-rankers and it can handle audio, images, PDF files. So like an implementation of this is available on like the NVIDIA blueprints, and like that's the standard RAG blueprint. And it's fairly easy to set up. Now, we have all of this static information, but most of the questions that SRE engineers generally ask about are pertaining to live data. And the next step is to connect our AI to some of those live signals. So this is where tools come in. tools are essentially functions that you write around functionality that you want the LLM to have. So for instance, if I have a function or a tool that says get recent alerts, when I provide that tool to the LLM and the LLM decides to call that tool, what's actually happening is that it's calling an implementation of that function, which is hitting which is hitting my monitoring API. So most LLM frameworks allow you to define tools and provide tools. And an example of this is the get recent alerts tool that I've shown there. So it takes when I ask a question like show me the last 10 auth alerts, and I provide this tool to my LLM as well, it allows the LLM to decide when it wants to call that, and get the response, and then respond based on that. Yeah. Now, an important safety pattern you can consider here is maybe start with just read-only tools first, and log the actual JSON response as well, so that when you do get the response, you can verify it against the actual thing and build a little more trust in your system. I'll show an example of where something like this becomes a little more useful. So you have that signal there. That's obviously something's wrong with it, but you can't just feed that just like that into an LLM and expect it to give anything useful. On the 6th of October, I'm seeing that my signal is behaving weird. So the way I would go about this is that I'd run a simple forecasting model, or have a forecasting pipeline set up to essentially run simulations and identify anomalies. Forecasting models are incredibly straightforward to set up for fairly seasonal data signals. You can just run Facebook Profit or something like that. And you get these anomalies. And once you have the anomalies, you can essentially keep a store of the anomalies. And you can be fairly creative in how you store it. You can keep the expected value versus the actual value, deviation from the expected value, and all of that information. Now I write a tool. So this is in one of those LLM frameworks, how tools are defined. So I have a get anomalies function where a description is written for that tool, what it does, and the arguments that it needs. So it takes a service name, allowed service names are there, start time, end time, and optional if there's a data center field or something like that. And the actual code of what this function does is implemented by me. So when I expose this, when I make this tool available to an LLM, what the LLM would do is when it gets my question, it decides to call this tool and then respond to the answer. Now, tools essentially let us do fairly powerful things in fairly easy ways. So something relatively easy to do is get real-time incident reports. During incidents, a question that is almost always asked is what's going on, what's happened till now? And as long as you have tools to get alerts, get previous incidents, pages, or the actual channel discussions that are going on there, it's fairly easy to set up a prompt template which more or less collates all of this data and generates a quick response. It's fairly easy to extend this as well into an executive report versus an engineer report. Even though it's fetching the same data, the prompt that is finally used at the end can have different templates based on who is asking. And so an executive might be more interested in the impact, the duration, the commitments, and maybe the engineer wants to know more about the timeline, what commands have been run till now, things like that. So with just an extension of adding an additional prompt, you can create something that is unique and adds value and saves a lot of time in writing incident reports, at least initial runs of incident reports. We also have this automated in a bunch of Slack channels, such that if someone asks for it, it can intermittently write it and as a message that only you can see so that you can be up to speed on what's happening. Another thing that's like fairly popular is writing weekly reliability digests. Like this is incredibly straightforward to do. Like all it needs is like a way to like query your incident tickets from that week and also the major change logs. And based on this, you channel it into some kind of template that you have, and you have a reliability digest which runs every week. Maybe it's not something that's fully automated. Maybe it's just something that generates a draft, and then like you can go edit it and then send it. But again, it saves time, and it provides value by you not having to like sit on the droning task of just like writing a full report. Another thing is on-the-fly plots. Again, this has caveats, and like it is restricted to like certain types of fairly easy plots. Assume you have a function that can return SLOs as a time series, and another that can plot time series data. Then I can actually just ask for an SLO for this time duration for this particular service. It'll then, based on the LLM's capabilities, go first, fetch the data, and then call the function to plot the series. And I get an image and a summary of what's going on. Yeah, that's mostly about like tools. Yeah. Now, tools are great for like synthesizing what's happening, but the next level of value is in understanding why something's happened. And to do that, we can't really expect to give an LLM a bunch of logs and a bunch of alerts and expect it to actually figure out what's happening. There's a lot of intricacies involved in most of the systems that we maintain and monitor, and giving it the right context is the challenge. And that's where we believe, and we have had success using simple Bayesian networks. In plain English, it's just a map of how components depend on each other with probabilities. So it enables us to essentially ask questions like, given these observed failures, what is the most likely cause? And it's not exactly a simple bare bones dependency graph. Each arrow has a probability assigned to it. And it's not something that's automatically created or anything. Like this, you or like the service owner essentially sit for maybe a few hours to like map out all your dependencies and figure out what can be observed and how do you decide if that observed state is good or bad. And based on that, you map out all your dependencies and give guesses for the probabilities on what is most likely and how often it is that that's the case. And it adds a lot of value. Firstly, it fits SREs because they encode dependencies fairly explicitly. Every engineer during an incident is more or less making a mental map of, okay, this is dependent on that. A Bayesian network more or less lets you map that, essentially lets you make that map visible and shareable. Secondly, they handle uncertainty. Instead of like making it a single alert causing like, this, it could be more like you can balance multiple weak alerts to have something that is stronger than the individual weak alerts. And third, they directly answer the question that is almost always asked, which is, given these symptoms, what's the most likely cause? And this is where another benefit of the Bayesian network comes in, is that when you go about defining your system as a Bayesian network, you are in that process understanding gaps in your observability. And that's where you can maybe add some additional alerts so that you can formulate it into a better network structure. Now, okay, how does all of this tie into an LLM? Well, a Bayesian network is mapping your dependencies. When you run the network, it gives you a probable cause, and you have all your alerts and your logs. This adds so much more context into an LLM that when passed, you get a much better response. The key here is not that it's perfect, but it's consistent. And we see like the same reasoning, and it's explainable because you can trace it back to which signals push the probability up. Of course, I want to add the major caveat that it's a suggestion engine and it's not an oracle. So how good your Bayesian network is based on how much time you have spent into modeling it. Yeah, moving on. We wanted to get into AI-assisted resolutions. That's what all of this was about from the start. So we want to make live changes in prod, but it's high risk. What if the AI-generated command just gets the namespace wrong, or it ends up restarting the wrong service? And the way we have more or less gone about it is we initially run Bayesian networks to identify the most likely broken component. Then we identify the relevant playbook corresponding to that component. Now, once we have the playbook, we use an LLM to generate a candidate command. Then we go through multiple filter criteria, something like, okay, forbidden zones, forbidden commands, no delete commands, things like that. Then it goes into a human approval stage where you have a candidate command and a filter for the resources across which it's going to be applied on. And then it's the human job to approve this particular command so that it executes across our resources. The flow is fairly simple. The Bayesian network is identifying the likely problem. The LLM finds the relevant playbook, generates the command to fix it, a second check to verify that everything's OK, and then a human approval. It's not like we are throwing some logs at an LLM and expecting it to do wonders. There's a lot of work around carefully curating context and controlling the information that is going into the LLM. The idea is that LLMs in its current state do have a lot of knowledge, but they can cause risky changes. And the idea is that we use our expertise to control and build systems that behave in ways we expect it by building and representing the right context to assist the LLM. And this is what we use for and we have been using pilot runs of this with rollout restarts of services where we are noticing failures. And it's been saving a bunch of time. And with that, I would like to hand it back to Scott.
Yeah, so just to kind of summarize and come away with the final conclusions here. So, I mean, SRE is already managing uncertainty every day, right? Just in our normal course of life. And AI just represents just another type of uncertainty that we have to deal with. So it's not new ground necessarily. It's just a new kind of tool set that we need to get used to. And also, success does not come from avoiding risk, right? It's using the tools you have to systematically understand and mitigate that risk, which is right in our core competencies. And the big question we kind of get asked, and our leadership drives, the question is, will automation replace us? Are we just building automation to replace our jobs? And the answer is yes, we are. We should always be trying to automate ourselves out of a job. But it's not so much, it's more about this version of the job that we are doing so that we can move on to the next evolution of what SRE is going to be, right? So like it says here, the biggest risk isn't adopting AI, it's being left behind, right? As others learn to use it more effectively. So with that, I think that concludes everything.